Let's take a look at some more problem solving, geometry and uniform motion. We got something called an angle, and that's how much this is opened up. That right there. Excuse me. So here's our starting side, and if we go up to here, that right there is 90 degrees. Now if we start over here and we go all the way over to there, that's 180 degrees. And if we got our starting side here and we're go over here, that's 370. Now if we got our initial side here and we go all the way around, and our terminal side is the same as our initial side, this is 360 degrees. So went all the way around. So if this is 90, about halfway is 45. This right here might be about 45 degrees. Well, we have complementary angles. Assuming I'm spelling that correctly. When you got complementary angles, that's two angles that add up to um, 90 degrees. And then you have supplementary angles. These are two angles that add up to 180 degrees. And that's what these first problems revolve around. So let me bring it up here. There we go. So it says find two supplementary angles such that measure of the first angle is 3 times measure of the second. So we got our first angle and second angle. Now the reason why I set these up in this form is because they refer to a first angle and a second angle. And one of them is being put in reference to the other. It says such that the measure of the first angle is 3 times the measure of the second. So the first is being put in reference to the second. So first is being put in reference to the second. Well, the one that's being put in reference to is our x. And it says the measure of the first angle is 3 times the measure of the second. Well, if this is x, 3 times that will be 3x. Now it says that they're supplementary, which means they add up to 180 degrees. So we take our first angle, which is 3x, plus our second angle, which is x. That should add up to 180 degrees. Well, 3x plus x gives us 4x. Now we're solving for x, so we'll divide both sides by 4. And those 4's cancel. And I think that gives us 45 degrees. 90, yeah, 45 degrees. So that means our second angle is 45 degrees. Now total they add up to 185, so this one has to be 135. Find two. Okay, they're asking us to find both of those. So those would be your answers. Let's look at the next problem. Find two complementary angles such that the measure of the first angle is 35 less than the measure of the second. Well, again, it looks like they're putting one angle in reference to the other. So let's go ahead and write first angle and second angle. And see what's being put in reference to the other. Such that the measure of the first angle is 35 degrees less than the measure of the second. So first is being put in reference to the second, which means this is x. And it says such that the measure of the first angle is 35 degrees less than the measure of the second. Well, if this is x, 35 degrees less will be x minus 35. Excuse me. Now they say these are complementary, so they add up to 90 degrees. So we take x minus 35 degrees plus x is going to give us 90 degrees. Well, add together the x's. X plus x is 2x. Take the negative 35 degrees to the right side, and it becomes a positive 35 degrees. Add those together. We get 125 degrees. Yeah. And then divide both sides by 2. And these 2's cancel. And that gives us 62.5 degrees. So our second angle is 62.5. Now total they add up to 90 degrees, so the other one will be 90 minus that. Let me see. So 90 minus 62.5. And that gives us 27.5. So this one is 27.5 degrees. So those would be our two angles. Now if we got a triangle, that's what the next problem is referring to. Well, we got an angle here, we got an angle here, and we got an angle here. All the angles inside of a triangle add up to 180 degrees. So they add up to 180 degrees. Let me start a new page and we'll work the problems dealing with that. Actually, I think there's just one. Maybe there's more than one. Let's take a look at this one. They give us a picture. It says find the measures of the angles of the triangle. Well, we got x plus 83, 3x minus 1, and 5x plus 8. This angle plus this angle plus this angle is going to give us 180 degrees. So we got x plus 83 plus 3x minus 1 plus 5x plus 8. And I'm not putting it, but these should be degrees on here. What did I just put? 0. It is nearly 9:30. Time for an old person to go to bed. Okay, let's try it again. 180 degrees. Now I'm not going to worry about degrees because I know they're supposed to be in degrees. So I'll add that on later. Okay, so combine together like terms. X plus 3x plus 5x. This plus this plus this. That gives us 4x plus 5x is 9x. Combine together numbers. 83 minus 1 plus 8. Let's see, 83 minus 1 is 82, plus 8 is 90. Equals 180. Well, get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on one side, numbers on the other side. So I take 90 over. And we got 9x is equal to 180 minus 90. 180 minus 90 gives us 90. And then last step, divide both sides by the number in front of your x, which is 9. And we get x is equal to 10. And just about there. There, those cancel. Okay. So our first angle was x plus 83. That's this right here, x plus 83. So if I put 10 in for x, I get 10 plus 83. So that one's is 93 degrees. Now our next one was 3x minus 1. It's a second angle. This one right here. So if I put 10 in for x, I get 3 times 10 minus 1. 3 times 10 is 30, minus 1 gives us 29 degrees. And then the last one is 5x plus 8. So I'll put 10 in for the x. I get 5 times 10 plus 8. 5 times 10 is 50 plus 8 gives us 58 degrees. So these would be our 3 angles. Now I don't draw these very well. Every one I draw comes out looking like a 60-60-60 type of triangle. So you have to use your imagination on that one. But let's take a look at our next one. It says in a triangle, the second angle measures 3 times the first. Measure of the third angle is 40 more than the second. Find the measures of the 3 angles. So it talks about a first angle, talks about a second angle, and it talks about a third angle. Now let's read a little closer. In a triangle, the second angle measures 3 times the first. So second is being put in reference to first. So second is being put in reference to first. The measure of the third angle is 40 more than a second. So the third angle is being put in reference to the second. Okay. So this one's being put in reference to this one, and this one's being put in reference to this one. So the one at the very bottom is our x. Well, let's go back and read a little closer. Second angle measures 3 times the first. Well, if this is x, 3 times the first will be 3x. Now the measure of the third angle is 40 more than the second. So it's 40 more than this, and this is already 3x, so this will be 3x plus 40. Now, what they don't give you in the problem is that all the angles add up to 180 degrees. So we can add the 3 of those together. It's that equal to 180. So we got x plus 3x plus 3x plus 40 is equal to 180. Well, 3x plus 3x is 6x plus x is 7x plus 40 equals 180. Get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on one side, numbers on the other side. So I'll take the 40 over, and it becomes a negative 40. Combine together numbers at any step. 180 minus 40 is 140. And last step, divide both sides by a number in front of your x, which is 7. And we get x is equal to 20. Those cancel. Okay, so this first one, it would be 20 degrees. Now the second angle is 3 times that. Well, 3 times 20 gives us 60. And that adds up to 80 degrees. Now I don't need to plug in x here, because if these add up to 180 or 80 degrees, in total they have to add up to 180 degrees, this has to be 100 degrees. And those will be our 3 answers. Now this next one gets away from the angles and starts talking about some other geometry. So let's take a look at it. It says the width of a rectangle is 20 meters less than half of the length. Okay, so width and length. Okay, the width of a rectangle is 20 meters less than half of the length. So the width is being put in reference to the length. Like that. Which means this is just going to be our variable, L. Instead of x, I chose L for length. Width of a rectangle is 20 meters less than half of the length. Well, half of the length. Well, that's 1/2 times L. Now, 20 meters less, that means minus 20. Okay. And then it says find the length of each side of the triangle. Width of the rectangle is... okay, the perimeter is 200. Well, we got a formula for a perimeter for a rectangle. It's 2 times L plus 2 times W. L is our length, W is our width, and P is our perimeter. Well, it tells perimeter is 200 equals 2L plus width, the W. Well, we just said that's 1/2 L minus 20. So we put that in there. Well, 2 times 1/2 cancels each other out and leaves us L. And 2 times negative 20 gives us negative 40. What we're doing there is getting rid of parentheses via the distributive property. Well, combine together like terms. 2L plus L gives us 3L. Get everything with an L on one side, numbers on the other side. So I'll take the negative 40 over the left side. And it becomes a positive 40. Remember, when you take anything across your equals, your sign changes. Add numbers at any step. 200 plus 40 is 240. And then divide both sides by the number in front of your L, which is 3. And we get L is equal to 80. Those 3's are canceling. Okay, so length is 80. Now our width, that's 1/2 times our length minus 20. This time I'm going to go ahead, since we know what L is, it's 80, and I'll plug it in here. Well, 1/2 times 80 gives us 40, and 40 minus 20 gives us 20. So our length is 80, and our width is 20. And those would be our answers. And let me start a new page. And let's look at the next problem. Okay, so a rectangular field has been divided so that the length of one of the parcels is 3 times the other. Smaller parcels are square and larger parcels are rectangle. Okay, so we got this right here, square. Rectangular field has been divided so that the length of one of the parcels is 3 times the other. So this length here, let's say that's x. So there's 1, 2, 3. Divided so the length of one of the parcels is 3 times the other. So if this is x, this is 3 times that, so this would be 3x. So I looked at this distance here and I tried to do 3 of them. Okay. Square, large parcels, rectangle. Okay, so that's what they give us. They said this is a square, so that has, if this side is x, this side has to be x, this side has to be x, and this side has to be x. Now, if this side is x, then this side has to be x. And for this to be a rectangle, if this is 3x, this has to be 3x. Okay, so that's our picture. And then it says if it takes 220 meters of fencing to enclose a field and divide it into 2 parcels, find the dimensions of the field. Okay, so total, all this fencing has to add up to 220. So I'm going to have x plus x plus x plus x. That's those 4 x's there. Then plus this x. And then plus 3x plus 3x. And that's going to add up to 220. 1, 2, 3, 4, 5 x's. 4, 5. Okay. Now, it really is just simple as that. You wouldn't even have to set that up. You know, it's 1, 2, 3, 4, 5. 5 x's plus another 3 is 8, plus another 3 is 11. So, combined together like terms, that gives us 11x. Well, then divide both sides by the number in front of your x, which is 11. And we get x is equal to 20. So, this dimension here, that's 20. Now this distance here would be 20. Now this is 3 times x, so 3 times 20 would give us 60. So that tells you the distance of the different sides here. Total, it's 80 here and it's 20 here. Now if they ask us for the individual pieces, this would be 60 by 20, and this would be 20 by 20. But that would be our problem. And let's look at a distance. Distance equals r times t problem. This is motion. R is your rate that you're going. T is the time that you've gone, and then d is a distance. Now, this right here, the time is in hours. usually. Though it doesn't have to be. I mean, you could have a different problem where you measure it in minutes or seconds or something, or even milliseconds even. But if this right here, R, is in miles per hour, then this one has to be in hours. If our rate was something different, like miles per second, then time has to be in seconds. So they do have to be the same. That's really the only condition there. Well, let's read this. Two trains leave, traveling the same direction on parallel tracks. This is train 1. And this is train 2. And they're both leaving along parallel tracks. One train is traveling 80 miles per hour. So let's say this one is going 80 miles per hour. And the other is traveling at 30 miles per hour. So this one would be 30 miles per hour. How long before they are 300 miles apart? Okay, so obviously this one's going faster. So what they're asking is, when is train 1 and train 2, the distance between them is 300 miles apart. So that's what they're asking. This train's going forward, this one's a little slower, and when are they going to be 300 miles apart? Well, what they're asking is, when is the distance of T1 minus the distance of T2 going to equal to 300. Well, now distance is given by this formula, R times T. Now they've been going the same time, so T for both of them is going to be the same. This one's going, its R is 80, so I'll put 80 in for the R, and this will be T for your time, minus, this one's going 30 miles, so this would be 30, and then T is still just T, and then that's equal 300. So again, we're looking at the rate times time of each one of these. That's what gives us the distance it's gone. Well, 80t minus 30t is 50t. Equals 300. And we're solving for t, so we'll divide both sides by 50. And we get t is equal to 6. So the answer would be 6 hours if it's asking for time. How long before they're 300 miles apart? Yeah. So our answer is 6 hours. And that's actually the last problem in that section. So let me save this video.